Hi everyone, welcome to Pi Day. I've got Stuart Coggins with me as my partner in crime, and I've got Jane Hall as well. Jane, over to you.
Hi everybody, thank you for joining us for Oracle's Pi Day, which is slightly reversed for our dates, which is 3/14 and 14/3. We hope you have a great day. There are plenty of sessions to get involved with, and we look forward to seeing you across the full day. There are trials available, which you can sign up for. If you have any questions, please put them in the Q&A, and we will help to answer you throughout the day. And without further ado, I will hand over to Ali to get started.
Thank you, Jane. So again, welcome everyone. So today we're going to talk, as part of this first session, we're going to talk about Kubernetes and Arm with Oracle Cloud. And basically, we've got a very a small demonstration about how you can use Arm and Kubernetes to develop your applications in the cloud. Okay, so the agenda, so going beyond the agenda, the Raspberry Pi using Arm, a quick primer on Kubernetes and the Oracle managed service for Kubernetes, and how you can support multiple architectures with Kubernetes, and finally a hands-on lab. And we've got a short announcement at the end, which we hope will be interesting in terms of how you use Kubernetes in terms of various application of Kubernetes in the cloud and in on-premise as well. All right, so my name is Ali Mukadam, and I'm a product manager with the Oracle Cloud and I work on Kubernetes, various cloud native integration with C and CF. And I'm going to be talking a little bit, giving you a bit of a primer on Kubernetes. So until very recently, the way we have been doing developing applications and deploying them is we have been building our applications, and then we have been deploying them on various hosts, where hosts is usually either a VM or bare metal servers. Now, the problem with that is that whenever the application crashes, or where you need to do an upgrade, or you need to scale, or even the host just crashes, the recovery time for you to do that is quite a lot. So, and there are many other things that we need to handle. Now, what we have done in terms of accelerating the startup time of your applications and building them and packaging them is we started to use containers. And containers significantly improve the startup time of your application and the way you package the effort you require to package your application and rolling them out. Nevertheless, you still need to be able to detect those failures wherever you're running those containers, whether you're running them on VM, whether you're running them on on bare metal, or even mixed workload. And this is where Kubernetes adds the help tremendously in terms of the reducing the startup time as well as the process of self-discovery. So Kubernetes, whenever there are failures inside your cluster, Kubernetes can detect those failures and can redeploy your pods and your applications across an entire fleet of servers within your cluster. So Kubernetes consists of worker nodes and control planes, so it's able to scale. You are able to scale it up and scale it down gracefully. So if you're relatively familiar with Kubernetes, so we'll do a quick primer on what OKE is. OKE is Oracle's managed service for Kubernetes. So we've got two control plane nodes. We've got one control plane node and a worker node. In the control plane node, these are the components of the control plane, consisting of the controller manager, the Kube API server, the scheduler, the cloud controller manager, and the etcd. Whereas in the worker node, this is where you will be deploying your application. And the interesting thing is that you can deploy many architectures, many shapes, basically. And you control this using the concept of a node pool. All the worker nodes in the in a node pool have a similar shape. So in this node pool, for example, they all have the x86 shape, whereas in the one below, they all have the ARM shape. And in a node pool, you can also control the number of CPUs available, as well as the memory available. In this way, you can make sure that your applications or your various microservices are right sized, and you don't need to over allocate resources. Now, additionally, the way OKE works is that the control plane nodes they run in the Oracle managed tenancy, whereas the worker nodes they run in your tenancy. So from a cost perspective, you don't, as a customer, you don't need to pay for the control plane nodes. Which if you're doing DevOps and you are start creating clusters and tearing them down significantly can add quite a lot of cost to your bottom line. So whereas when you're not paying for these for the control plane, they can contribute to significant cost savings. So essentially, as a customer, what you pay for is just what you use. So the worker nodes, the amount of memory, storage, and the load balancer. That's it. Okay. Now, in terms of the application, so when you're adopting ARM in the enterprise, it's still about running the application. So you need to make sure you package your application as container images, that your images are architecture specific. So they are built to run on ARM. You need to create your Kubernetes manifest so that they can accommodate ARM deployment as well. You need to ensure that the packages or the framework libraries that you use, they cross-compile, and as well as ensuring that your runtime environment can accommodate changes as well. So these are some of the considerations that are required when adopting in the enterprise. Now, we've got a Handson lab for you folks who are attending. So, so first, if you've already got an OCI account, so you can use that. And if not, you can register for a free trial. And what you're going to do is that you're going to create an OKE cluster with ARM-based compute for your node pool, and then you're going to access the cluster with in Cloud Shell, and then you're going to deploy a very simple workload. All the instructions of this lab is available as part of my colleague and teammate Jivan's GitHub project. So you can see the link here. I'll let this stay here for a few minutes so that you guys can copy this. And then we've got an announcement. So last Friday we released the Cluster API for OCI. Cluster API is a Kubernetes sub-project. It helps in terms of providing declarative APIs and tooling for your Kubernetes clusters. It helps you simplify your management lifecycle. It provides a single and consistent experience, both with managed and self-managed clusters, as well as with multiple infrastructure and cloud providers. So you can imagine, for example, if let's say you have a management cluster, and from the management cluster, you can provision various workload clusters. management and workload clusters are terms in cluster APIs. So from the management clusters, this is where you drive the creation and upgrade and destruction of the workload clusters. Whereas the workload clusters are where you will be typically be running your applications. So you can imagine from the management cluster, you deploy you provision various workload clusters where you will be deploying your applications. The links, you can test drive the cluster API in the free tier as well, and the links to the documentation are here. Okay, now without further ado, I'll just jump on the on the lab. So let's go right at the beginning. So what you will do, you will start by creating a cluster. Use the quick create, and in the beginning you make sure you set it to the public endpoint and private workers. Once the cluster is created, you will add a second node pool with arm shape. So make sure you select A1 flex. Keep it to 3 nodes. You don't need to change any of the additional setting. Once the cluster is created, what you will do is you will launch the Cloud Shell. And I'll show you how to launch that in a minute. Launch the Cloud Shell, obtain the kube config, and then what we are going to do next is we are going to deploy an application that is distributed half on an x86 and half of it will be on ARM. The reason is because typically when in the enterprise, as you adopt ARM, you want to ensure take it for a test drive and gradually adopt it and move the workload from x86 to ARM if you want to. So what you will do is we will deploy a simple tomcat application. Here, this is not usually the way we deploy application in Kubernetes. This is a kind of a lazy hack. But basically, we download the sample WAR file, we add it to a config map, and then from the config map, we'll create the application. This will create a load balancer, and it will also then, we will be able to access this eventually. All right, now what I will do now is I will show you how to in the OCI consoles. Once you have logged into the Oracle Cloud, what you will do is click on Developer Services, and then click on OKE. You will land here. I already have a cluster created. You will be creating. I'll walk you through the steps from here. Click on Create Cluster, and then quick create. Launch the workflow. Make sure you select public endpoint, the private workers, and then click Next. Review if you want to change, and then you'll click Create, and you can wait for it until it's created. Once the cluster is created, what you will do is you need to get you need to obtain the kube config. Click on Access Cluster, select the Cloud Shell access, copy this, and then you will run this in the Cloud Shell. The Cloud Shell can be launched by clicking on this icon that you will see at the top here. Click that, and you will see this. It will start an instance of the Cloud Shell for you. Now, if I run the kube control get nodes, I've got an alias created for kube control here. Right, and you will see that I've got 6 nodes, 3 of them, 6 or 5, it seems. 5 of them, 3 of them are x86, and 2 of them are for ARM. Right now, the next thing what you will do is we want to look at the labels, for example. So if I say instead, copy these commands, and then you can just paste it here. So you will be able to see all the details so for example, you can see the the kernel version, the container runtime, etc. Right? Now, what you will do is you will download this WAR file from here. I've already downloaded it to my Cloud Shell. You can see that here, and you will create this tomcat.yaml by copying this command here. What this command does is it creates a deployment for Tomcat, and then it adds some topology constraints, specifying the images for Tomcat, and then the volumes to be mounted. Similarly, it also creates a service, and it sets it of type load balancer, so that when we deploy, it will create a public load balancer for us, and we can access it. Right. So I have already I have already created my application here. So if I do kubectl get pods, so you will see that I've got my pods running here, and I want to check my service as well. And now over here, I can see this is my public load balancer IP address. And if I look at my load balancer, if I navigate in the networking section, look at the load balancer, I will see that this is the public IP address of the load balancer. You can copy the IP address from here, and then opening a new tab, and put a /sample over here, and you will be able to access the sample Tomcat application. That will be basically the exercise of creating the sample application. Similarly, the one last step is if you want to do creating a clinical example, you can clone this repo from my colleague Jeevan's GitHub project, go to the Kubernetes Arm, and then applying the manifest, and you can check the deployment status. So we're going to do that right now. Okay, and let's go back to Cloud Shell. I want to make sure I've got Jeevan's project here. So I'm going to go in here and then paste this here. So this will basically be creating a WordPress application running inside Kubernetes, and eventually it will create a persistent volume, the deployment, the service, etc. That's basically what you will be doing in the lab. If you have any questions, I'm happy to answer these now. Are there any questions in the right now?
Not at the moment, Ali.
All right.
Feel free to ask in the questions.
Okay, I see there's a couple of okay. This has been they have been already answered. So yes, you will have access to this. You will be providing all recording sessions. Stuck at trying to get the Oracle Cloud account. Okay, Jane is helping. All right. If you have any questions, feel free to put them in the Q&A, and we will answer those.
So there's one question there, Ali, about the CLI. Do you want to take that?
I'm trying to see where it is.
So is there a CLI needed to install as the person missed the first few minutes? So.
Oh, okay. So if you use the Cloud Shell, you don't need to install anything. It's pre-installed for you in the Cloud Shell. So in the Cloud Shell, you've got Git and Kube Control already pre-installed for you, as well as the OCI CLI. If you're doing it locally though on your laptop, then you do need to install OCI CLI. You do need to install Kube Control, and you need to make sure that your OCI configuration is created locally on your laptop. On the Cloud Shell, it's all done for you according to your profile. So that's why we are, for the purpose of this lab, it's easier if you use the Cloud Shell.
So the OCI does have a pretty neat way of fast tracking the OCI configuration. So there are some methods just to give you what you need to do that through the console there. Thanks, Ali.
No worries. So in the meantime, if some of you are trying to get the account created or have already set things up and waiting for the clusters to create, what I'll do is I'll walk you through some of the neat features of OKE. You will see here is a node. The node pool is a concept where all the worker nodes as part of the node pool, they have the same shape. The shape consists of the image that you want to use, the number of CPUs that you want to assign, the amount of memory, any network security posture in the form of network security group, as well as any particular image as well. So if a worker node as part of a node pool fails, OKE under the hood handles that failure and automatically spins up a new one for you. So that ensures that you have the necessary amount of computing or memory that you require as part of your application. Additionally, what we have is a number of security features. So for example, earlier when I was creating the cluster, I mentioned, create it as part of a public endpoint. This is just for the purpose of this exercise. Usually for creating real clusters, production grade clusters, you would be using a private endpoint, which means that your cluster is not publicly available. Optionally, if you do require public workers, and we do have some customers who need this capability, the workers can be created in a public subnet, and you can access them directly. You, as part of other security features, we can we can ensure that any image that you consume has to be signed by a certain number of keys. So even only by you would be adding the keys here, and these keys would typically be stored in OCI's KMS. If any image or anybody tries to deploy any image that's not signed by those keys, then that deployment fails. Likewise, the underlying HCD that is part of the OKE cluster, you can choose to encrypt those as well. So we strive to make things as secure by default as possible. Any other questions? Either about OKE or about the lab itself? Feel free to ask. Okay, I'll leave this here for now, and we will be monitoring the Q&A. The value, hello, Shadab. We are doing the labs at the moment, so if the presentation is actually finished, so I'll put the link in the window here for everyone.
It's loud and clear for me, by the way, just saying.
What's the NoSQL database running in Oracle Cloud? Do you want to take that one, Stu?
Sure. So Oracle has its own NoSQL database. So it's just called NoSQL, ironically. I think there's many flavors, but there is an Oracle version of NoSQL in the cloud. I'm not sure if that answers it or not. Ollie, if you just want to go to the console.
Yep.
Just go to the database page, go to the left menu, top left, and then databases under Oracle database, next one down.
Yeah.
So there's the Oracle NoSQL database there.
Maybe I should try to create one. Create a table here. Set your capacity, key columns.
So we also run a MySQL in the cloud. We've also got an autonomous JSON database in the cloud, as well as obviously Oracle database. So we've got a number of flavors of database that are available. And the newly released MongoDB API, which you can use, which is pretty good. So that's the MySQL in the cloud. We, if you enable HeatWave, gives you some really super fast analytics as well, if that's required.
There's so this is the HeatWave that Stu is talking about, and gives you some crazy fast query capabilities. Okay, and the neat thing is that you can turn it on and off as and when you need.
Well, actually, HeatWave just enables itself when it thinks it needs it. So you can run a query with 1,000 records and it won't bother. If you run it with 10 million records, there's a good chance it's going to use HeatWave. So we've got a really nice demo for HeatWave, where it basically determines whether or not it needs to use it. And I think Larry talked about a multi-cloud version of that just recently, so that's exciting too. There is a question there on the question chat. I can't seem to find advanced search parameters for geospatial indexes. Yeah, good question. Might need to look. There's a whole lot of spatial capability inside the database. We might need to specifically look at the use case there. But Oracle database natively has a very, very impressive spatial capability. So I'd be surprised if it's not there. It's not my forte specifically, but Dagan, if that's something we can find out more information from, perhaps you can get in touch with us. Jane, is there a way for people to contact us after the sessions?
Yes, we can take all of these questions, and also through the public Slack channel is a great way to get in touch, and we will share the link in the chat with everybody for future questions.
Thank you.
All right. The other thing is that in the console, if you have complex deployment or multi-region deployment, you can visualize your network and troubleshoot how things are, where things could be going wrong. So, for example, here I have a VCN, and I want to be able to look what's the routing map or the security map. So I can look at the routing map here. If there were many VCN, I would see them as well. So here I can look inside the network and see what's the traffic that's going here to the internet gateway. So that's everything. Whereas here this is going to the service gateway, and this to the NAT gateway. I can change and toggle the view to the subnet security map as well, and just to see if the right ports and the right destination are open and all that. So there's a lot of thoughtful, things we have done in the OCI console to make your life easier as a cloud administrator, and most as a cloud native admin or developer, to figure out how things are going. Right. There are additional questions either about OCI, OKE, or the lab itself. We are very happy to answer those. Thanks, Oliver. All the credit goes to my teammate, Jeevan. He wrote that lab. So in the meantime, I'll also just show you, folks, the cluster API that we just released. So you can reach it on oracle.github.io cluster-api-provider-oci. The instructions are pretty straightforward. You need to build an image, and then you can start with kind, or with K3s, or even with the OKE. So there are different paths to how you want to use it. We've illustrated all of this here, as well as what policies you require. Once that is done, what you need to do is create a management cluster. If you're using kind, that's pretty straightforward. With OKE, you would be basically repeating the steps that you just did in this particular in the lab that you just did, and then you can install the cluster API. From the cluster API, you've got a working management cluster, and you can create a workload cluster. You can also test drive other things like different kind of CNIs like Calico, Antrea, or some, if you have certain specific, network infrastructure that you require. If you want to collaborate with us, or you have additional features, so you can reach out to us on GitHub. And these are the issues that we have at the moment. We've just made that release, as I mentioned earlier last week. So we're quite excited about this. And one other thing is that the cluster API is that it also supports ARM-based deployment as well. So that is something we are quite excited about.
There's a question there for you, Ali.
Is there? Okay. How many CPUs does the instance have? Is that the number of nodes? Okay. So let's just go to the clusters. Okay. So a node pool consists of a number of VM instances, or bare metal, depending on which shape you choose. Each VM or each host that you select, you have created in the node pool, will have the number of OCPUs that you have specified. In this case, I have chosen to create a node pool of 1 OCPU. So each worker node, they will have 1 OCPU. Okay, is that the number of nodes? So no, so CPUs does not equal the number of nodes. You can have, for example, let's say I choose to create another node pool. I can choose to increase the number of OCPUs here, but the node pool, let's say, remains 3, for example. So nodes equal to VM instances, whereas OCPUs are the number of CPU threads, basically. right? Now, your second question is how this works in a multi-threaded environment. That's a great question, actually. The way it works, especially with with Go, is that we use especially for ARM, for example. Let me just come here. With ARM, we use a single threaded, so there's no throttling. It gives consistent and predictable performance across in all your cores across all your ARM-based workloads. At least the one that are part of this node pool. So, for example, if I have a Go application and I've chosen it to deploy within this node pool, then all the deployment that are in this node pool have the same consistent performance. If I create a new node pool with on ARM, but I choose to deploy to spread the application across both node pools, again they will have the same performance. Okay, I hope that answers your question. So the benefit of of having a multi-architecture and multi-mix workload is that you can choose to gradually introduce ARM into your fleet of your workloads. So as you get more comfortable deploying on ARM and you move your workload to ARM, you can gradually move your workload across. You can right size your deployment according to your workload, and with ARM, it's faster to provision and also more cost effective, depending on your applications, obviously. Could this webinar be posted somewhere? I think, Jane, that's a question for you.
Yeah, all of the content today is being recorded and everybody will have access to all of the sessions that we have over the series of the day. So yes, you will have access to it.
Okay, I think there's another question from Dennis. Can't see the VM standard A1 flex option for some reason. So, okay, I'll walk you through this. So click on node pools and then click on add node pool, select A1 flex. Are you able to see A1 the flex here?
Said you can't see A1 flex. I wonder if it depends which region we're in.
Possibly. Which region are you trying, Dennis?
Yes, he's Stockholm. That's a good question. We might need to check on the availability of that one in Stockholm.
In Stockholm.
Yep. I don't have access to that region, Ali, so I can't see that one.
Let's see if I have. I do have.
Oh, look at you.
Okay, I'm not going to create one, but I'll just see if there is.
No, it's not there, is it?
Don't think so. Yeah. So you might, Dennis, you might want to try in another region, like in Ashburn or Phoenix.
I'm not sure if we can change regions, Ali, on the free tier.
Oh, okay.
I might be wrong. I think.
No, you can't change your home region after
No,
you've set it
you
up.
can't. No. Can you get access to another region, Bo? I can't remember.
You can sign up for another Oracle Cloud account and pick a different region when you set up your home one.
Yeah, that's what I thought. Okay. You're right, because I've got 2 free tiers, because I've got one running in Sydney and one running in London, and I've had to sign up for a separate free tier. That's a good point. Yeah, I think it looks like the A1 is not available in that region. So most of our services are available in most regions, but I think it was a bit unlucky in this case. It might be worth making a note of that for later presentations.
When is it coming to other regions? That's a good question. We probably need to get back to you on that one.
There is a web page for that. Just need to go find it for you. I'll see if I can find it.
It was on Javen's lab as well. I had the impression it was somewhere here in the lab, like you could verify which region has it, the direct link.
I just put it in chat.
Oh,
Ali?
thanks, Bo.
Yep.
Thanks, Bo. Much appreciated.
No worries. If you guys want to go there, it shows all features and by region.
So I'll put it here.
Excellent. Thank you.
All right. So you can see here what we have where. And
just try EMEA first. I'll leave you in APAC there. I think if Dennis is in somewhere near Scandinavia, then
okay.
Yep, Nordics.
All right. Yes, Nordics. Okay, we've got about 5 more minutes. Is that right?
Yep.
So if you've got any questions, feel free to ask. Otherwise, feel free to reach out to us in the Slack channel.
Dennis, we'll try and get back to you on the what services, specific shapes are available in what regions. If you let us know on Slack. Yeah, so it's obviously the compute is available. It's what shapes are available, and it could be, I don't know, but it could be that that particular shape is exhausted for some reason. But so I've not heard of that before. But let's look into it for you, and we'll if we can get in touch on Slack afterwards, that would be good. Otherwise, if you choose. Obviously, the US region that Ali was just playing in has it. I would suspect that London also would have those shapes available, but we can check for sure.
Let's try London then. I see what you did there, Stu.
What? Handballed it.
Yep. So
I've never.
ARM is available in London.
ARM's available in London. Okay. Yep. Cool. So we expect to see a cluster API demo quite soon, Ali?
Certainly. We are quite excited about it. We should have one. I don't know when we are planning exactly, but we are planning on one.
Yep. If anyone's interested, again, ping us on Slack, because that's an exciting development, and it's been a while coming, I think. So it's once we've got some collateral on that, we'd be happy to share. Straight out the oven, isn't it, Ali? Cluster API.
Yep.
Excellent.
It's it allows you to take to push the boundaries of Kubernetes on OCI further and faster. Provisioning and tearing down, it's just along with the flexibility, it's really cool actually. Okay, there's one more question. No, okay, this question has already been answered.
Disaster management. There you go. Do you want to take that one?
1 sec. I don't see the question.
It's in the Q&A panel from Dagan.
Disaster management. Can you please elaborate, Dagan? Are you referring to disaster recovery?
Certainly, we could talk about disaster recovery all day, but I suppose we do need to be a bit specific if it's about the clusters. That makes more sense. Yeah.
I'm just conscious that we have just a couple of minutes left, so I want to answer your question as accurately as possible.
I suppose, Ali, just let's make an assumption for a second. Yep. We cover just cluster recovery, just as a brief answer.
So you have there's a number of things that we can handle with in terms of disaster recovery. One, within the region itself, there are fault domains, there are multiple fault domains and multiple availability domains. So if there are failures at the node level or at the AD level, that can be handled. And then the second one is on the node pool level as well. So I mentioned the the self-healing feature of the node pool. If a node crusher fails inside a node pool, the OKE engine handles that automatically for you. You can also architect your infrastructure so that you can do cross-region disaster recovery as well. So typically in OCI, we tend to deploy, like for example, in Australia, we have Sydney and Melbourne. So we tend to deploy in two regions in a geographical location. So you can set up DR across various regions.
Dagen's just elaborated a little bit on the issue they've had with other cloud providers. Needless to say, our architecture is a little more resilient than what I can see there.
So that we are just over the hour. If we can continue this discussion on Slack. We'll reach out to you and carry this discussion. All right. Thank you, everyone, for your time. I hope you had as much joy as I had running this lab in playing with OKE and ARM. And have a nice day.